Hi there. Today I'd like to show you some basic operations in Sesam GeniE. Okay, now you can see this is the interface, the GUI, graphic user interface of GeniE of Sesam. And the version of this GeniE is version 7.2. Of course, there are newer versions nowadays, but this is the one that I have. And between different versions, there might be slight difference in the interface. Later on, we will talk about this. You can see now in the window there is some structure there, and this is based on the example B1. So if you can click here, help topics, or you simply press F1 in your keyboard, they will lead you to this help document, and you can find the GeniE examples, the B1. Okay, this is the PDF document of the tutorial of this example B1. So basically, you will create a new workspace and then specify what is the I section and what is the material properties. And you will specify a guided structure, which will help you to create your model with some key points in defined location. And you can, of course, you can copy paste if you have similar structures just by a single translation in X or Y or Z direction, or alternatively, you can create your structure by specifying the X, Y, Z coordinates of the starting point, ending point, for instance. And then you will add this support to define the boundary condition. And this one, actually, I received a question from a student today. They said in this GeniE that they don't have this insert menu, which we can see here. In the interface, we have on the top the menus, okay, but there is no insert. And on the left-hand side, you will have this browser. For the beginners, they like more to use the menu to control everything, but actually the browser is quite useful. Later on, I will also explain on this. Okay, you define boundary condition there, and to define the load case, what is the loading to your structure? It could be line load, distributed line load, or a point load. Okay, then you will start your analysis. By the way, for finite element analysis, you need to do a mesh to generate the elements. And in this simple case, the program, they will do it automatically, so you don't need to do that. And you have to specify what is the type of analysis. And in this one, we have only structure. There's no water hydrodynamic effect. So we just do a linear structure analysis, then start to run it. After just a few seconds, the program will finish the computation, and then you can go to the results presentation. So that is everything shown in this document, example B1. There are steps there. So for a beginner, you just need to follow the steps, okay, of this document. So go back here. We have menus on the top. Left-hand side, we have browser, and in between, there are the toolbars. Actually, you can move the toolbars to any place you want. That is a way to organize your toolbar if you prefer to do it here or there. Okay. Depends on your preference, how you can organize it in a better way. Okay, you can do it as you prefer. Then, as I said, we have this example B1, and this is the whole structure there. So you see, I'm rotating the model now. How I can do that? So you check this toolbar, you have rotate, zoom, and pan. Okay, So now this one is on. Rotate. You can use your right mouse button to rotate the model. Okay. By a rotation center. And you can zoom in, zoom out to make it big or small. You can pan it to move it left or right, up and down. Okay. And sometimes like you rotate it and you remove it, rotate it again, and you lost your structure. It's difficult to find it back. There's a very useful function of F9 to fit. Okay, click this fit or use F9 in your keyboard. You will have all the structure, the entire structure fitting in the window. Okay, and of course you can check here what type of a model to present. You can use the default display. So in this case, you see something else. The green one is the guided plane. This one is the distributed line load. And you have, of course, your structures as beams, and you have these supports. So if you want to check modeling, or you have these modeling structures only. Okay, so you don't see now the guided plane, the loading, just the structures with the support. And later on, there are some results presentation. Of course, I will explain that later. And here you can check the location. This is the LC is the load case. Okay, you have, if we check the structure, default display, you have load case number 1. This is the case, load case. If you stop your mouse there, you will have, you can see this brief instruction, the name of this applied load, and the values of it. You will see 0, 850, and 0. So that means in the y direction, you will have 850 Newton force there. If you change it to LC2, okay, you see this distributed load with the starting point and the ending point. And now they are the same, 650 in y direction. So this is equally distributed load. Okay, let me see what else we have here in the toolbar. We can use this one, dimension. Okay, click this one, and we can measure what is the height of the structure. It's 5 meters. What is the distance in these two nodes? Between these two nodes, 5 meters, and this one, 10 meters. Okay, when you deactivate this one, you can click there to delete. Right click to, okay, there's no delete, so just use the keyboard, delete. Are you sure? Yes, this one I delete it. Okay. Then the browser, you can check the structure. If you click here, structure, not any of the sub folder, just the structure, you will see beam number 1 to number 15. Actually, if let's check only the modeling of structure. If you click any one of them, you will see the right one in red. Okay, and this is the beam that you have, and you can even see the properties of it, which kind of sections is defined for this beam. And of course, you can right click to rename it. Okay, to any name you prefer, or you can click here properties to change it, to change the properties, materials, etc. And here the supports. Okay, do you remember we don't have inserts there? So one way to do this support is to click structure in the browser and supports. You will see these 4 supports already defined there. Okay, this support number 1, number 2, number 3, number 4. You can even right click, choose the properties. You will see What is the degrees of freedom constraint for this support? You will have X, Y, Z all fixed, and rotational 3, translational 3, rotational. Okay, of course you can change it to free or depending on your case. Now they are moving together because this one is picked. If you unpick this one, then you will be able to move them to check them separately. Okay, but now cancel it. We don't change this. If you want to add one more support, what you can do, just right click on the empty space, new support. You will have support name number 5 because you have 1 to 4. Then click here position, then move your mouse to the right hand side to choose any point. Okay, single click there, you will see the XYZ coordinates of this support. Then you can define one more support. If you click apply, okay, then it's there. If you want, you can delete that one. Yes. Okay, this is a way to do it. Alternatively, you can do that in the user manual, structure, support point dialog. So we see the same dialog. Okay. Even you delete the support number 5, but let's start with name number 6 because you can change it. Location, if you want, you can type. If you remember the format, just we need to type. I don't remember the place. It's 0, 0 and 5. Okay, I will give just a random point. And I will fix only 3 translational, or maybe just the vertical one, the Z. Okay, apply. Let me check where is it. Okay, mistakenly I did it there, but this is the point. Okay, and of course you can delete it. So from the menu or from the browser, you can add the support. Okay, and about the results presentation, you can go to Tools, Analysis, and Presentation. Of course, you have to start analysis by Activity Monitor, then start the run. In this case, I have already since been calculated. So after that, I can go to Analysis and Presentation, or you can use Alt+P, the short key. So here you can choose one of the load cases. And if you want to present the displacement, you can check the displacement in Y direction. That is the direction we apply the force. Apply. There's nothing there because now the setting is modeling all. You have to go to the results all. Okay. You will see a different colors. This is the contour plot. Of course, you can change the setting, how many numbers of levels you want to check, and the other options there. Okay, so this is the maximum. You can even present the maximum and minimum there. Okay, this is a maximum, minimum point. And of course, if you change to the other load case, apply, you got different results. Okay. And you may ask, from here, I didn't see very clear what is the deformed shape, since there's a very detailed deformation. Yes. And you can turn on, you can present this numeric annotation, right, to see the values. Okay, I turn off the maximum, minimum. You see values here only without structure because this is the results all. If you want to see the result together with the structure, results with mesh. Okay. Then you may say, okay, this beam is too big. I didn't see what exactly the value. Then you have this option in the toolbar to present structure as wireframe. Okay, this helps you to read these values better. And regarding the deformed shape, you can try to present it or not. then yes, setting. Because you see this one, the magnitude is quite small. It's 10 to the power of -4. Then if you use a scale factor, here you can specify a scale factor. Let's say 10,000, which is actually not normal, but in this case, we have very small deformation. We use this value. Okay, now you see it's deformed like this way. Okay, if you put just a scale factor 1, that is the true deformed shape. Here we have, and you can present also a reaction force in this case of Fy or any one of the components. Everything apply. Okay, you see here the values. Okay, there are 4 values of the reaction force, at least 4 supports. And for this reaction force, you can only present the results as numeric annotation. Yeah. Then there are a few more options that you can try to present. So I believe that is the basic operations I want to show you today. You will have the menus to show things, toolbars and browsers to give everything, different type of structure presentation. Okay. F9. Rotate the model. F4. Pan your model. F3. Zoom in, zoom out. Okay. Okay, that's the end of the video tutorial today. And I hope this one can be helpful. And bye, cheers.